Happy morning, dear friends. Here's yours, Dr. Rajanta. Welcome to Demystify with Ajay. Dear friends, today we are going to discuss the differentiation and the calculus using JAX. JAX actually is a linear algebra and automatic differentiation framework developed by Google and mainly for machine learning. It combines the capabilities of AutoGrad and its accelerated linear algebra. Of course, this accelerated linear algebra, it is shortly specified as XLA. So actually optimizing compiler for linear algebra and machine learning. In particular, it allows us to easily construct complex functions which automatic gradient computation that can be run under GPUs, of course graphics processing units, or TPUs also, so that is tensor processing units. On top of all of this, it is relatively simple to use. Actually, in this session we are just going to discuss how to make use of this JAX and just in time compiler get the gradient of a function and make use of this different computation device. And of course, for this we need the JAX package to be installed. And yeah, here we make use of this matplotlib package with the pyplot interface imported at PLT. That is also as usual. And since we are going to plot a function of two variables, we need to import the matplotlib 3D from the MPL toolkit package. And yeah, dear friends, here let me just here I just want to show how to define an JIT compiled function using JAX. So actually compute the gradient of this function and use a GPU or TPU to perform calculation. Okay, so first of all, what we need, we need to import the part of JAX library that we are just going to make use of it. So kindly just see here, this is what the JAX functionality that we have been included. And yeah, we can define our function with a JIT decorator that applied to tell JAX to JIT compile this function which is necessary. And what is the exact function? Of course, here we go with the function that is here it is just specifying f of x comma y which we are just going to specify as like x to the power of 2 plus y to the power of 2. Okay, and yeah, next we define a grid and plot our function. For that, yeah, of course we have already discussed about this line space in the previous session, and here we are just going to make use of the plotting. Okay, and yeah, dear friends, kindly just see, this is how you can just make use of the plot in grayscale. If you want to make use of it in the colorful manner or defaultly blue or any other color, yeah, you can just remove this alone. Okay, so you can just remove this and you can execute. It would be just shown it in different color. And yeah, here it is exactly the results of the plot here. And we use the grad function. Okay, we use the grad function and the JIT decorator to define two new functions that are the partial derivatives with respect to the first and second argument. And kindly just see here, this is the exact x partial derivative, and here it is the y partial derivative. And with the x partial, yeah, it is just defining as f comma 0, and for y partial derivatives it just specify f comma 1. And here we just get both the points. So here we just get the points. And yeah, whether first of all, whether checking the function, yeah, of course, we are just printing the exact value, that is 1 to minus 1. Okay, and yeah, to finish off, let's plot the partial derivatives with the exact plotting x, and here it is go. Okay, so this is how the exact partially derivative function with respect to x-axis, and here we just get the exact value, or towards that output we just say. So see here, this is how. And a quick check confirms that this is indeed a plot of partial derivatives with respect to x of the function f(x, y). Okay, so that is what here we just get in 3D function. Okay, yeah. Dear friends, here again I just want to give you a small input related to this JAX. See, actually JAX is an interesting mix of JIT compiler, and when on just and with an emphasis of fast linear operation that is combined with the power of autograd, which I just already specified. Okay, so with the power of autograd with the support of acceleration device. Okay, you need to make sure that you only use the NumPy module for JAX. For in the sense, you can just go for JAX.NumPy rather than the real NumPy. Okay, so JAX also provides a version of SkyPy package also. And unlike NumPy arrays, JAX NumPy array cannot be updated in place using index notation and assignment. Kindly just keep it in that mind. Okay, now let me just make use of this JAX. Let me just solve a differential equation. And here the same thing exactly, I just repeat it again. See, JAX provides a set of tools for solving a wide area of problem. And for you, and one more new information I want to share here. Yeah, I'm just going to make use of Diffrax package that provides a various solver for differentially equations, leveraging the power and convenience of JAX. Dear friends, in the earlier session we solved an relative simple first order ordinary differential equation, and yeah, here we are going to solve a second order ODE to illustrate the techniques. And here second order ODE is a differential equation that involves both the first and second derivatives of a function. To keep things simple, let me just go into solve a linear second order function. How it would be, just we are in second order. So in such a case, if it is second order, we have to make it dou square y by dou x square plus p of x dy by dx plus q of x into y, that is equal to 0. And here y is equal to y of x is a simple function of x to be found. And in particularly we are going to solve the exact equation. Let me just give one such an equation here. Okay, what we are just going to do is, let I just make it something similar to the above. And here it is minus 3x square dy by dx, and here it is q. For q, let I just give something as value of 1 minus xy. Okay, so here the initial condition, or y is equal to 0, that is y of 0, that is equal to 0, and y dash of 0, that is equal to 3. So that is what here it is specified. Note that this is a second order differential equation, so we need two initial conditions. Okay, so yeah, before we just solving the equation, okay, let I just make you one more thing. Actually, we need to reduce that second order to first order. Okay, so second order to first order differential equation that can be solved numerically. So to do this, we make a substitution, that is u is equal to y and v is equal to y dash. When we do this, how we are just going to get, yeah, of course, to our system here, du by dv which is equal to v, sorry, dx which is equal to v, and here dv by dx which is equal to 3x square v minus 1 by x u. Okay, and we also get the initial condition, that is u of 0 is equal to 0 and v of 0 is equal to 1. Okay, so as I have already specified, we need an difference package, so which I have already specified. This exact package we are just going to install, and along with JAX, and yeah, this is how it happens. Okay, once again I just execute it. As usual, we import an matplotlib for pyplot also for interface under the alias number plt, so that I have just already given here. And yeah, dear friend, how to use JAX and diffrex library to solve an second order linear differential equation, that is what we are in discussion now. Kindly just observe. So we need to set up our function that represents the system of first order ODE we constructed, and here we are just getting it in this function. So this is the exact function, we just get that. Okay, now we set up the diffrex environment that will use to solve the equation. So we will use the solver recommended in the diffrex quick guide. Of course, I also just specified that link in the description. Okay, and here kindly just observe what are all the things there here for this ODE term and drop IV. So this thing, by using this, yeah, we are going to make use of the solver recommendation in the diffrex. Okay, and once after, we are going to use diff eq solve routine from diffrex to solve the differential equation on the range. Yeah, of course, kindly observe the range 0 to 1. So that one 0 to 1, and kindly just observe here, we are going to name it as towards the solution. We have solved the equation now. Now what we need? Yeah, we need to extract the value for y from the solution object. And that one is specified here. So kindly just observe, this is what. And what about this? Y is equal to ys. Of course, here the first column is y is equal to u. What's next? Of course, we are just going to get that output in x and y. So, of course, it is what in going to be in matrix format. And let me just plot it. And here nothing much to have it differentiation. And kindly just observe, this is what. And here we can see that when x is close to 0, okay, when x is close to 0, yeah, the solution is approximately linear, but later on the solution becomes non-linear. See, actually the exact x range might be too small to see the interesting behavior of this system. Okay, so actually here I just want to specify one more thing, dear friends. Actually, diffrex is built on top of JAX and provides various solver for a differential equation. What can be further? Of course, in this we can use the Dorman prints that we have just used as a solver. So again, I just to show you where we have just used it. So see here, yeah, this is what Dorman prints, that is 5 of 4, which we just say dorp RI 5 solver class, which is another example of an Ranjikuta method for solving ODE is similar to Ranjiguta method, which we have actually which we didn't include it. But anyhow, behind the scene, this Diffrex translate this ODE initial value problem into a controlled differential equation, okay, which is then solves. So this makes Diffrex able to solve other kinds of differential equation besides the simple ODE. Okay, so one of the goals of the library is to provide tool for numerically solving stochastic differential equation, that is SDEs, and since it is based on JAX, it should be easy to integrate this into other JAX workflow also. It also has support of for Bragg propagation, so through various adjoint method. So anyhow, so yeah, this is what we have done it, dear friends. So of course, I think this exact video would be interesting for you, and stay updated on our upcoming sessions or say tutorials and learning resource by subscribing to my channel. And yeah, by subscribing, you will ensure that you never miss out on the latest insights and techniques that we are just going to discuss in the series on machine learning specialist. Okay, together we will continue to explore the frontier of knowledge and innovation. And here I just want to add up one more thing, dear friends. Yeah, of course, thank you for your active participation. So many are just making questions or inquiry and thanking. And of course, it is really an active participants and enthusiasm and dedication to learning. I am just able to see that. And remember, the skills and the concept you have gained here are just the beginning. Keep participating, keep exploring, and keep pushing the boundaries of what's possible in machine learning. So yeah, if you like this exact video, kindly just don't forget to hit the like button. Kindly just subscribe, and if you have any doubts or any clarification, just put it on to the comment box, and see you in the next video, dear friends. Happy learning.